Welcome back everybody to the third and final part of this tutorial. In this part I will show you how to visualize the clock frequency of your microcontroller using the real-time debugger. If you didn't see the first part, the introduction, please click in the left top corner. If you didn't see the second part, which I try to show you how to write your code, click in the right top corner. Hope you will enjoy it. Welcome back to our last part here, which we will try together to visualize our variable, our clock in real time. So for that we have to download the STMSTUDIO, the real-time debugger. So for that you go to the ST website and looking for the STMSTUDIO, then you go down and click in the download button here. So let's go back here to our STMSTUDIO. So our goal here is to visualize the variable inside the flash memory of our microcontroller in real time. So this is a good things. So for that, let's see you something. So how to do that? Click on the file here and click import variable here. So we're gonna looking for our project. So go to the project directory here. So here we are in our project directory and go inside debug, then exe and select cout. So as you can see here, we don't have no variable, we don't have any variable here. So for that we go back to our IDE. We're going to create two variable here in order to visualize it in our STMSTUDIO here. So for that we go back to the RCC source file and we're going to looking for two function here. So the first one is the RCC get clock frequency. So this function returns the frequency of different on-chip clock, the system clock, the high-speed clock, peripheral clock 1 and peripheral clock 2. So for that, so we copy this and we go at the end and we paste it here and we delete this. I'm gonna write here debug purposes, and so the parameter is pointed to an RCC clock type def structure which will hold the clock frequency. So this is a structure, so we're gonna looking for this. We select this, right click on it and go to the definition. The definition of this structure is inside the RCC header file. So we go this down and as you can see here, the structure have 4 elements. The first one the system clock frequency, the high-speed clock frequency, the peripheral clock 1 and peripheral clock 2. So we're gonna declare this variable structure here. So we go before our function and we gonna paste this and we go back and I'm gonna call it as the same as this one. So we copy this and we paste it. So we have here the RCC clock is a new structure type of RCC clock type def. So we copy this and we put it as a parameter for this function here. But be careful here, the RCC clock, this parameter is a pointer to RCC clock type def. So we have to add it and here that's mean this is the address of the structure, not the value. So now we finished with the first variable here. Let's go and check looking for the second function here. So the second function here is RCC get system clock source, and here as you can see here, this function return the clock source used as system clock. So we have here 3 value. If 0 mean the internal clock is used as system clock, if the value is 4 mean the external clock used as system clock, if the value returned is 8 mean the PLL is used as system clock. So we copy this and we paste here and we're gonna declare a variable here the same as this one. I'm gonna call it system clock source. I'm gonna call it like this, and we're gonna copy this and put it equal, mean this function return this value. The value returned by this function is gonna found it inside the system clock source. Now we finish with this. Let's download and debug here. And now let's go back to our STMSTUDIO and go back and import variable here. And here a new variable added, but this is not what we're looking for. The APB1, the APB1 is inside this function here, but we don't need this. We don't get our two variables, which are the RCC clock and the system clock source. So maybe you encountered you had this problem before. So to resolve this problem, we have to copy the declaration of these variable outside the main file. So these variables are called local variable because they are declared inside the main or inside any function. If the variable is declared inside the function, it's called a local variable. If the variable are declared outside the main, that's called global variable. So to resolve this problem, we copy these two variables here and we put it outside the main, and we copy this second one and we put this, and we're gonna find these two variable here. So we download and debug again. And we go again, import variable here, and here we got our variable, the RCC clock, the structure here we got, which have 4 elements, and the system clock source. As you can see, the RCC clock, which is a structure, and this system clock source here. So we select these 5 here and we click import. So these variables are here right now, and we select them all and we drop and drag here, and we're gonna select, instead of curve, we're gonna select a table here. So here we're gonna read the value in real time in this column, and the read value column. So we check if okay, everything okay, and we select the serial debugger for our board. If you have another board, you have to check which communication debugger communication you have. So we select the serial ST-Link, the serial debugger, and we click on this icon here, and as you can see here, here the value read it real time. So the system clock is equal to 168 million, which means 168 megahertz. The high speed clock is equal to 168 megahertz also. The peripheral clock 1 is equal to 42 million, which means 42 megahertz. The peripheral clock 2 is equal to 84 million, which means megahertz. So let's check here. Go to page 18 again. Page 18. As you can see here, we compare, because our goal is to obtain the maximum frequency. For the system clock is 168 megahertz. The AHB1 and AHB2, the high speed clock, is 168 million, also the maximum frequency. The APB2 is 84, the peripheral clock 2, and the APP1 is 42 megahertz. So we made it. We put all the maximum frequency. We set up all the maximum frequency, and the last one, the system clock source. As you can see here, the system clock source. So we go back here, go definition, and as you can see here, here its return value of 0.08 means the PLL used as system clock. So everything is correct. So now let's stop the debugging here and go back to our IDE and let's change some value here. For example, let's divide our maximum frequency by 2. So we're gonna select this value here. We're gonna divide it by 4 instead of 2. So let's download and debug. We're gonna notice that the frequency is divided by 2. So we go back to our IDE and we're gonna see after the frequency will be divided by 2. So we go this, and here we is. The high speed, the system clock is divided by 2, 84, 84. The peripheral clock 1 is divided by 2, 21. The peripheral clock 2 is 42, and the system clock is equal to 8, of course, meaning the PLL is used. So now let's go back and reset this value here to obtain the maximum frequency. And now let's stop this, and now let's try to use the external clock directly as the system clock without using the PLL. So for that, so let's go back here, and this part we're gonna let it like that, let this part like that, because this is enabling the external clock, and this is the test of the external clock, if it's okay or not. Here we're gonna increment the PLL because we don't need it right now, and this flash state latency, you're gonna see it later. Wait a minute, and you're gonna select this one. We're gonna change it to the external clock. Gonna change the PLL by the external clock. That's mean the external clock is selected as system clock source directly. And we go back to the flash latency here. We change our frequency. Here we use directly the crystal, the external cluster. The frequency of the external cluster is 8 megahertz. So we are here in this range here. So we can put the latency at 0. So we can change it here 0, and we download, and we're gonna see the result. And before moving, we have to stop the debugging here, then go back. We're gonna here we have the system clock equal to 8 as the external crystal frequency. The high speed clock is equal to 8 megahertz. The peripheral clock 1 is equal to 2 megahertz. The peripheral clock 2 is equal to 4 megahertz, and the system clock source is changed to 4. What does mean? Okay, so we go definition here, and equal to 4 mean the external clock is used as a system clock. That's okay. So we stop debugging here, and we press Ctrl Z to reset our value here. Okay, 2, and that's okay. So right now, let's try using the internal clock through the PLL. So for that, we'll use the internal clock. So we're gonna delay this part for enabling the external cluster clock, and erase this part here, of course, because this is a test if the external clock is okay or not. And we're gonna delete all this part here, and I'm gonna enable our internal clock. So go to the RCC source file here, and go here to the RCC high-speed internal command here, and this function enable or disable the internal high-speed oscillator. So we copy this, and before the PLL, and we paste it here, and we're gonna write enabling the internal internal clock. Enable the internal clock here, and we're gonna put this parameter here can have two value, enable or disable. We're gonna enable it, of course, here. Then what we're gonna do right now, after enabling here the RCC clock configuration, we have to select the source as internal clock source. So we go to this function here, and the first part, I'm going to change the first parameter here. We're going to select the internal clock source. That's mean the internal oscillator clock selected as PLL clock entry. And we're going to change this value because the RCC internal clock is equal to 16. In order to obtain 1 megahertz as VCO input, we're going to choose the PLLM equal to 16. So 16 megahertz divided by 16 gonna give us 1 megahertz. So I think everything is okay here, and the flash latency, everything okay. So here in this example, we will try to set the system core clock and the buses at their maximum frequency, as we did in the first example, but now using the internal clock 60 megahertz RC internal clock through the PLL. So now we put 16 here, the internal clock, we select the internal clock, then everything is okay. Now we go back here, the flash latency is still at 5 because we using the maximum frequency as the first example, and the RCC system clock source is 2 PLL clock. So now let's let's debug and see the result, and let's open the debugger here. As you can see here, also the our system clock is equal to 168 megahertz. The high-speed clock is equal to 168 megahertz. Peripheral clock 1 42 megahertz, peripheral clock 2 84 megahertz, and we're using the PLL. As you can see here, the PLL. So we got the definition here. The 08 mean the PLL is used. So now let's finish with the last example here. We're gonna use the internal clock directly as the system clock. So what you're gonna do here, so here the enabling the internal clock is okay, and we're gonna remove all this, the PLL configuration, and here these are okay. The flash latency, we're gonna use the our frequency will be equal to 60 megahertz. So for 60 megahertz, our rate state is equal to 0. So we put 0 here, and we change this as the internal clock. We copy this and we paste right here, and let's download and debug. Okay, there's an error here. So normally the debugger is used, we missed this, so we have to stop the debugging here in the STMSTUDIO and go back here, and let's start download our program here. So here we go back and we open this. As you can see here, the system core clock is equal to 60 megahertz, which is the internal RC oscillator. The high-speed clock is equal to 60 megahertz. The peripheral clock 1 is equal to 4. Peripheral clock 2 is equal to 8. And the system clock source is equal to 0. That's mean, go to the definition of this. Mean 0 mean the internal clock is used as system clock. So that's okay. So for example, let's divide the peripheral clock 2 divided by 2. So the peripheral clock 1 equal to peripheral clock 2. So let's try this. I'm gonna divide this by 4, and I'm gonna stop this. and we're gonna download here, and we'll see here this frequency peripheral clock 2 will change to 4, and here change to 4. That's all for this tutorial. If you found this tutorial interesting and helpful, please push the like button and subscribe to this channel. If you want to help this channel, there's a link in the video description below. So thanks for watching, and see you next time for more tutorial video.